The 5-year forward rate would be equal to the spot rate of yen per dollar times the ratio of the future value in 5 years of 1 yen to the future value in 5 years of $1. The logic is that if we can invest directly in yen for 5 years, we can convert 1 yen into the future value of 1 yen in 5 years. Alternatively, we can convert the 1 yen into dollars in the spot foreign exchange market. Invest that dollar principal for 5 years to get the future value of dollars and contract today to sell those dollars in the forward market to get back to future yen in 5 years. If the two amounts of future yen differ, there would be an arbitrage available in which you would borrow future yen where they are cheap and invest in future yen when they are expensive. As there are bid-ask spreads in the foreign exchange market and in the external currency market, we do not convert from one currency to another at the same spot or forward exchange rates, and we do not borrow at the same rate at which we lend. The absence of covered interest arbitrage, therefore, is characterized by two inequalities. We cannot profit by borrowing the domestic currency, converting to the foreign currency, lending the foreign currency, and converting to the domestic currency in the forward market. Similarly, we cannot profit by borrowing the foreign currency, converting to domestic currency, lending the domestic currency, and converting to the foreign currency forward market.
The sequence of transactions needed to do a covered interest arbitrage out of the Japanese yen into US dollars. You would first need to borrow yen from the bank at the bank's ask interest rate. Once you own interest on the yen, you would have to return the yen principal at the end of the investment horizon. You would then be able to convert the yen principal into dollars at the ask spot exchange rate of the yen per dollar. You would pay the ask rate because you are buying dollars from the bank with yen. You can then invest the dollar principal at the bank's bid dollar interest rate. Since you would know how much the dollar interest plus principal would be at the end of the investment horizon, you would now be able to sell that amount of dollars forward for yen. The forward contract would be made at the bank's forward bid rate of the yen per dollar. If the amount of yen you get from the forward contract exceeds the amount of yen that you owe the bank from the initial borrowing, you have successfully done a covered interest arbitrage. It can be an arbitrage opportunity as it reflects the fact that the counterparty risk differs across the banks. The market knows that the default risk of the French bank is higher than the other banks. Hence, the French bank increases its promised deposit rates above the rates charged by the other banks with a lower default risk. The perceived arbitrage opportunity would be deceptive in this case.
The interest rates on the US dollar denominated bank accounts in Mexican banks are often higher than the interest rates on the bank accounts in the United States. The reason is that Mexico has periodically gotten into balance of payments difficulties and suffered severe depreciations of peso. During these periods of crisis, the Mexican government converted dollar denominated bank deposits into peso denominated accounts at exchange rates that were unfavorable to the depositor, effectively expropriating some of an investor's principal. If there is a possibility of this type of risk or just higher default risk by the Mexican bank than the US banks, the higher dollar denominated Mexican deposit rates would be required to induce depositors to invest in the Mexican banks. As a French representative of a company selling soap in Canada, a company is interested in euro profits. Selling soap in Canada will give a company a Canadian dollar revenues. The euro value of this Canadian dollar revenues will fall in value if the Canadian dollar weakens relative to the euro. To offset this loss in a value, a company should borrow in Canadian dollars.
So moving on to the last question, how does a coupon bond's yield to maturity differ from the spot rate that applies to cash flows occurring at the maturity of the bond, and when are the two the same. So firstly, let's consider what's the yield to maturity of a bond. A coupon's bond yield to maturity is the internal rate of return that sets the present value of the coupon payments and the principal payments equal to the bond price. In other words, it also means that it is the anticipated return on the bond that the holder expects if he holds the bond till maturity. So basically, the yield to maturity equals the spot interest rate at various maturities only when the term structure of interest rate is flat, as shown in the diagram, and when the spot interest rates at various maturities are identical. That is represented by the flat yield curve diagram on the right hand side.